Let's explore some facts important in meteorology. Cooling faster than the surroundings, the air column is understood as stable, whereas cooling slower than the environment air column is unstable. Stable air column is cooler than its surroundings, so it sinks and compresses. Unstable air column is warmer than its surroundings, so rises and expands. Temperature reduction with rising altitude is lapse rate, environmental lapse rate being average of global tropospheric lapse rate, that is 6.5 degrees centigrade per kilometer. Moist adiabatic lapse rate is variable depending upon the water vapor present, being 3.6 to 5.5 degrees centigrade per kilometer, and dry adiabatic lapse rate is 9.8 degrees centigrade per kilometer rise of a particular air column. Air column ascended adiabatically, then due to expansion because of pressure difference, the air column temperature drops. If air column thrusted downward adiabatically, then due to pressure soaring outside the air column, its molecule gets compressed, becoming it comparatively hotter. Stability is measured by measuring the air column's rise or sink with respect to its surroundings. If air column being hot and thereby less dense, then such air column would ascend up to similar surroundings. However, if air column being colder and thus denser would sink below up to the equivalent adjacent surroundings of similar thermodynamical air column conditions. Stable condition for a dry air column, DALR greater than ELR. Then if air column being ascended it gets cooler than surroundings, whereas downward thrusted air column could be hotter than surroundings. Unstable condition for a dry air column, DALR less than ELR. Then if air column being ascended it gets hotter than the surroundings, and if being thrusted downward the air column could be cooler than surroundings. Absolute stable air column equals ELR less than MALR mounting air column would cool quickly with respect to its surroundings in spite of the saturation condition attainment. Air column soaring diminishes once got equivalent level of such air column containing surroundings. Absolute unstable air column equals ELR greater than DALR ascending air column would cool slowly with respect to its surroundings in spite of the saturation condition being attained. Rising of air column would take place due to hotter, less denser conditions. Conditionally unstable air column equals MALR lesser than ELR, that is further lesser than DALR. Unsaturated conditionally unstable air column, cooling quickly with respect to surroundings at dry adiabatic lapse rate would resist its rise. If jerked for saturation attainment, then such conditionally unstable saturated air column through moist adiabatic lapse rate becomes cooler by a rate slower than that of surroundings, and therefore makes it relatively hotter with respect to its adjacent surroundings, compelling it to further ascent. Solar radiation is the radiation energy emitted by the sun through electromagnetic wave form. Radiation depletion took place through water vapor, ozone, carbon dioxide at a particular wavelength. Rayleigh scattering considers size of particles that are lesser than the wavelength of light, in which intensity is inversely proportional to fourth power of wavelength of light. Ms scattering is scattering due to size of particles larger than wavelength of light, unattenuated radiation that takes place. After scattering, reflection and absorption is direct radiation. Those that being reflected, scattered and absorbed in atmosphere arrived later around terrestrial realms are called diffused solar radiation. The net effect of the previous two discussed is global solar radiation. The peak solar intensity is 2028.8 watt per meter square at a wavelength of 0.48 micron meter. Terrestrial solar radiation consists of solar spectrum that varies from 0.2 micron meter to 0.3 micron meter. Ultraviolet ranges from 0.2 to 0.38 micron meter, having 88 watt per meter square energy consisting of 6% spectral significance. Visible ranges from 0.38 micron meter to 0.78 micron meter, carrying 656 watt per meter square of energy and 48% spectral significance. Infrared lies in 0.78 to 3 micron meter, having 623 watt per meter square of energy and 46% spectral significance. 0.98% of total emitting has got range between 0.25 micron meter to 3 micron meter. Ultraviolet less than 0.286 micron meter is being absorbed through ozone layer. Violet got spectral significance between 400 to 446 nanometers range, blue occurs in 446 to 500 nanometers range, green lies in 500 to 578 nanometers range, yellow ranges 578 nanometers to 592 nanometers. Orange occupies 592 to 620 nanometers span, and red obtains 620 to 700 nanometers range. Climate change being stressed through 13th vital aim regarding climate awareness and mitigation for achieving sustainable development goals. The exposure, vulnerability and coping capacity are the fundamental traits that are considered for climate change impacts over certain demographic residing in a particular geographic region. The slow onset climate stressors are rainfall patterns, sea level rise, glacial retreat, temperature increase, ocean acidification, land and forest degradation, desertification, biodiversity loss and salinization, etc., while the immediate fast onset shocks are flood, drought, tropical storm, wildlife, heat wave, dust storm, etc.